right now. Maybe next time we should have this type of webinars on a party or something, hopefully. We'll see. Today, I will try to deliver again a presentation that I delivered at 3D Experience World this February in Nashville. It was a hands-on class. So I know that many people wanted to attend this presentation. Unfortunately, there were only 30 computers in that room. So 30 lucky users were able to get on the computers and get an actual training class. Now this is going to be a webinar style. So you probably will not get the hands-on component right away. That being said, I know that Alin is recording this presentation and you will get a recording. And also we're going to send you a file set with everything I'm using right now. So if you later on would like to try again, following some of the techniques I'm going to share, feel free to do that. Now, my hope is that you will take what we're going to show you today and you're going to apply directly to your assemblies. So this way, you don't really need to use the file set that we'll have. There are going to be a couple of things that we're going to focus. So what are the takeaways? Let me share with them right away. For me, the assembly visualization tool has been one of the best troubleshooting tools for large assembly performance. Now, that being said, this webinar is not about large assembly performance, but I'm going to touch a little bit about that. By the way, if that is a topic of interest to you, let us know, and maybe we can do another redelivery of one of our SolidWorks World or 3D Experience World presentations from this year, focused on large assembly and large drawing performance. Actually, yesterday I heard that some of our slides from the 3D Experience World large assembly, especially on the large assembly performance, have already been used by other presenters. So I'm happy to know that we are popular and we can help users, even though we are not the ones who are presenting that material. So that is good. Also, the assembly visualization is going to be great for a few other things. And I just mentioned a few of them. Fantastic for quickly sorting your assembly, grouping things together based on all kind of crazy criteria, quick selections, color coding your components in probably the fastest way possible, and also creating all kind of other deliverables like reports, analysis sheets in Excel. So we're going to take a look at this. Now, the audience for this can be almost anybody who is a consumer of the CAD data you create. Even if one of you is not really a SolidWorks user, you're still going to have a benefit by attending this presentation. So one of the hardest questions to ask is, what information do you need from the assembly? And maybe I shouldn't say it's the hardest question to ask, but it's the hardest question for me to envision all the possible answers that somebody would get. So what I did, I put together this little chart, word chart, and I'm wondering if any of these keywords, it's something that you'd like to just to snap your fingers and get an answer from your assembly. Like, hey, assembly, you have 10,000 components. Tell me, give me a quick report about which components are manufactured, which one are purchased, and if they're manufactured, where are they coming from, right? So this type of information in almost no time at all, kind of real time. And of course, other things, slowdowns, right? Troubleshooting slowdowns. So quick access to the information, and then also actions that you can do to the assembly. And again, read this word chart and maybe write in the chat if there is any word that resonates with you. Actually, allow me to put the previous word chart up. Is there any word that resonates with you, something that you would have ever needed to get out of an assembly without having to create a drawing, without having to create bill of materials, without having to go to PDM? So feel free to either type it in the chat or just make a note. Okay, so this is about the information contained in the assembly, and this is just a few things. Notice I selected the most popular, the ones that I encounter working with users like you. And these are the actions. So once you find that information, what would you like to do with the assembly, right? So these are the actions. Feel free again, if you want to share with us some of the actions you'd like to do, create a quick report. I don't want to influence you, but these are some of the actions that you can do. So for those of you who have not a chance to attend my presentation or our classes, my name is Alin Vargatu. I have been working with CAD for a long time. I use AutoCAD, I use Mechanical Desktop, I use Pro Engineer. I also got basic training in CATIA, Inventor, and a few other CAD softwares. I have started using SolidWorks around I got some training in '99, but really for professionally, I started using in 2002. I was working for a tool and die shop with a very ambitious owner who would go after any job out there. We served any industry you can name, and we had projects that were differing day and night from each other. So not just tooling, we did all kind of automation jobs, gauges, fixtures, repairs, you name it. We probably were a part of that. And as a designer, what that means, you have to reinvent the wheel every day, and you need a tool that would enable you to do that. And for me, the tool was SolidWorks. I was actually a customer of my current employer, so Javelin Technologies. I was a customer for about 7 years, a bit more than 7 years. And I can tell you, I was fortunate enough that our company was under subscription with Javelin. So I used and abused the technical support quite a lot. And I took any training they had available. So that was really great. In the process of using SolidWorks in all these various areas, I actually fall in love with the software. And I was looking for somebody to pay me full time to play with it all day long. Now, this is not really play, but I was fortunate enough to be accepted to work for Javelin Technologies. And now, even though I'm not doing active design anymore, I live vicariously through you, working with you and actually seeing the amazing design, the amazing products you design and manufactured, learning from you about what type of tools and techniques you already found at work, and then becoming a partner of your company, putting our minds together to find better ways to improve efficiency, improve productivity, reduce errors, and things like that. So for example, this presentation is a result of multiple consulting jobs that I have with quite a few of you. And this is how they were, this is how I gathered the data and I put it together. The other thing that I'm really proud of is being an active member of the SolidWorks community. I'm delivering presentation at any SolidWorks user group meeting I'm being asked for. I'm attending and delivering presentation at SolidWorks World and now at 3D Experience World. Posting articles, and actually I'm going to share with you one of the articles that's relevant to this specific presentation, videos, blog articles, things like that. So I'm also the founder of the SolidWorks Power User Challenges, and I'm mentioning that because since we started the newest course that we have, which is the CSWP exam preparation workshop. I don't know if you're aware of that, but we now have a very rigorous workshop that maximizes the chances of passing the exam. One question that I'm getting asked by my students is, okay, Alin, so I'm going to become a CSWP and then a CSWE, an expert. What's next? What else can I get? And my answer is, if you want more challenges and you want a different type of certificate, maybe not issued by the Asse system, but by your peers, you can try to participate in the SolidWorks Power User Challenges, because if you win those challenges, you're going to get a certificate of recognition from your peers. And who doesn't want a certificate from Deepak, right? He's one of the most known SolidWorks users in the world. So just so you know, if you're curious, we can provide you with links to read about past challenges and also to be notified when new challenges appear. But that being said, let's talk a little bit about where we are. So Javelin Technologies is the Canadian VAR. We cover Canada from coast to coast. And one thing about our customers, they are really well supported. So if they need help at any time during the day, maybe it's for somebody in the central Canada, if they wake up really, really early, there is an application engineer ready to help them in Dartmouth. Or if it's really late, there is somebody in Vancouver on the West Coast or in Victoria that's qualified to help them in SolidWorks. And that being said, let's go directly on the presentation. How many of you have assemblies that look like this? You wanted, or somebody wanted, to ensure that the right material is applied to all the parts. So that's perfect. And also the right appearances is applied to those parts. And the result is something that looks very realistic, right? A lot of gray on the screen, which is great for marketing, maybe. It's probably less good if you are working with this assembly. I mean, for me, it would be very hard to figure out where a sub-assembly starts and another sub-assembly finishes, or where a part starts and another part. Where is the boundary between two parts? Because both of them have the same color. So wouldn't it be nice to have the ability to instant color these components, to press a button and have each part colored differently without losing the color that you assign to the material? So maybe creating two display states, one with individual colors assigned to each component at the part level, and one with the material colors, right? Or if you want, you might want to apply colors to the sub-assembly components. So let's see how easy it is to do that. I'm going to switch back to SolidWorks. At this point, I'm using SolidWorks 2020 Service Pack 3. And allow me to open this assembly. Oh, by the way, when you work with SolidWorks, I hope you guys know that in order to go back to the home, you can simply double click on the screen, right? So if I double click right now, I'm getting to the home panel. And here I have, for example, the recent documents, recent folders, quite a lot of information. So let me open this assembly. It's those of you who attended our assembly modeling class, you probably remember this engine in lesson 7, if I'm not mistaken. Now, I had really fun with it by applying the right appearances and also by doing an exploded view. It's actually more than one exploded view. If you notice here, I'm actually apply exploded steps at the sub-assembly level, and I'm reusing them at the higher level assembly. But I think I'm going on a tangent right now. But if you're curious about creating very fast, well-detailed exploded views, that's the way to go. So notice I'm under the Evaluate tab right now. And I have here the assembly visualization. You can also find it under Tools menu. You can also search for it. So allow me to click on it. The moment that happens, by default, if you use the standard templates that you get from SolidWorks, your assembly is going to look different right away. It's going to get colored based on a certain logic. So notice how this space that was used for the feature manager now got another tab called Assembly Visualization. Also, the feature manager has the components nicely nested here, right? The default for the assembly visualization is something similar to a feature manager, but having the components actually displayed in a different manner, different sorting. So the default is that each component is going to have all its instances grouped together. So for example, I have here 4 first rings, 4 second rings, 18 balls for a major ball bearing. I have also 3 columns, right? So file name quantity, and they give you the mass as a criterion that you might want to investigate. Now, the first two columns are hard-coded in SolidWorks. You cannot change them, you cannot hide them, you cannot delete them. Anything after the first two columns is customizable. And you can add up to 6 more columns to this panel. Let's take a look at, first of all, let's focus just on the first job that we have, to color components at the part level. So I told you that the moment you switch assembly visualization, SolidWorks by default is going to attempt to color your components based on all kind of criteria. What control you have as a user is based on this color bar. So when you click on it, notice actually as I'm hovering over it, there is a pop-up saying toggle color on and off. So when I click on it, it's actually turning it off. When I click on it again, it's turning it on. And also notice that the range of colors, it's a spectrum, right? From red, and if I go all the way down, goes to blue. And I'm going to talk more about that in the next phase of this webinar. One thing I wanted to make sure is that you know that you can stop the coloring of your parts by simply clicking on this color bar. So if I click on it, it's reverting to whatever colors you have in the active display state, right? So if I'm going to the configurations, I have only one display state called material colors. I go back to assembly visualization, I'm still in that display state, right? It doesn't change. So by clicking on the bar, you simply override the current colors in that display state, and new colors are being applied to your components. Now, one cool thing about this, I can sort these components based on any of the headers of your assembly visualization column. So for example, I'm going to go by file name. Notice the first time you click, it's going to go from A to Z. The other way, click again, it's going to reverse the order. So how can I ask SolidWorks, instead of assigning colors as a spectrum, to assign individual colors to each part? Very simple. I'm going to right click on this bar, and notice I have here the option to group identical. So once I do that, each part is going to get its own color assigned. Now, there is very possible that some colors might repeat themselves because there are only 48 available colors. It's not using like 256 colors, which I'm going to say it's very smart. By keeping the number of colors small, it makes sure that they are easy to differentiate between them. If I would have a really close shade of the same color, 2 shades, maybe pink and not so pink, would be very, very hard to see them. SolidWorks also does a pretty good job of making sure that 2 adjacent components have different colors. So this is for the part. Now it's time to discover another button in the interface, and that is this one. So this button allows you to switch from the flat view, which is going to show you just the parts, no assembly whatsoever, to the typical nested mode. So here I have each top level component in my assembly colored a different way. So for example, I know this is one sub-assembly. Okay, for example, the blue ones are actually, these ones are 4 instances of the same sub-assembly. And notice how they are being colored the same. So it's very, very useful, like instant coloring. So as you can see, step number 1, or the first benefit of using assembly visualization, can be achieved with really a couple of clicks. Color the parts, color the components. The problem is, what do you do after you get out of the assembly visualization? Notice I'm going back to my original colors. And you're going to say, okay, this doesn't really help me much. I would like to preserve those colors after I get out of the assembly. So let's paint them fast and then have them in the assembly. Which brings me to the second point. You can quickly create display states once you have the colors that you want. So let's attempt that. I'm going to switch back to assembly visualization. Notice it remembers my last choice, right? And remember how to switch between assembly and parts. You simply click on this button. Now, one thing I want to tell you is that the colors that you have right now are being reassigned or repainted every time you do this switch. So SolidWorks doesn't really remember that this is blue. If I go out and back in, notice now it's a different color. Let's do it again, and it's picking a different color, which in a way it can be good. If you're not really happy with the colors you currently have, you can maybe flip a couple of times and until you get a color scheme that works for you. And then let's locate this right pointing arrow, which is going to give us lots of other options. One of them is add display state. And this is what I'm going to do right now. I'm going to click add display state. So if I switch back to the display states, notice I'm still in the active display state, material color. So the moment you get out of the assembly visualization, you return to the current colors. But I have a brand new display state, which is the one that was painted by the assembly visualization. And my advice is to name them in such a way that it makes sense. So in this case, I'm going to call, let's say, part level colors. Right? So it's a quick way to color code your parts just like that. Let's build another one for the assemblies or sub-assemblies. So I'm going to switch back to assembly visualization and move on to the nested mode. Okay. Do I like this? Maybe I'm not a big fan of this pink. I'm just going to switch back to the parts back here. This is too gray. I don't really like it. Let's do it again. This is very clear. I can see the differences between parts pretty well. So let's save another display state. So I'm going to add another display state, switch back to the configuration manager, and maybe name this display state as top level colors. Right? So let's see material colors, part level colors, top level colors. So what did you achieve right now? First of all, you ensure you didn't change the original color, because it looks like somebody in your company really likes to have the actual material colors. But very fast, you create working display states. I guess it's much easier for me to work in this display state because I can tell the parts apart from each other. Or in this display state, if I'm working with mating sub-assemblies, it's so much easier to tell them apart this way, right? So those are the first two reasons that I'm going to say are pretty compelling to become accustomed to use the assembly visualization. Now let's move on to become to get to the point where we can master the assembly visualization. So what about sorting, and sorting from more than one criteria? Okay, let's switch back to the assembly, and let me switch back to material colors and turn on assembly visualization. Notice the colors that I have right now are individual to each top level component. I'm gonna reset this, so I can right click on this bar and use the option reset. Right, so when you reset, it automatically turns on the spectrum colors. So they are going to be color based on different criteria. Now, to color based on names doesn't make too much sense if you use a spectrum. But if you talk about quantities, that makes a bit more sense. So let's switch to parts, and let's use the mass as the criterion for sorting. And allow me to put the top, the heaviest part right at the top. At this point, notice how SolidWorks uses the blue for the heaviest and the red for the lightest. And in between, it's trying to find a tone of a combination of these two colors that is weighted based on these numbers. So it's going to look closer to blue if it's really heavy, and closer to red if it's very light. Okay. Now, if you think like me and you think, okay, I think red should signify heavy stuff and not blue, maybe it should be the other way around. That's easy to change. You simply click on the slider, double click on the slider, sorry, and you have access to the color. So I can pick up this little slider and I can make it red. And then I'm going to scroll down at the end, double click on the bottom slider, and I'm going to make it blue. So I kind of change the colors inside out. So I know this is the heaviest, right? And then you go backward, down from there. What if you have more than one criterion? Maybe you deal with revision and sub-revisions, minor revisions and major revisions and minor revisions. Maybe you have A, B, C for major revisions and 1, 2, 3 for minor revisions. And you'd like to use both criterion for sorting. In this case, I'm going to use the mass and also the surface area. Okay. So let me add another column here. I can go to add column. And the moment I add it, I can also specify what criterion I want to use here. Notice SolidWorks gives me automatically 5 favorites. So kind of shortcuts. I can go total weight, density, volume, surface area, right? So probably I can click surface area and there you go. I'm getting the surface area. One thing that I'm not really happy with this interface, but I know that SolidWorks is working on it, is maybe having a better way to auto fit these columns. Otherwise you have to do a lot of manual dragging of these bars, right? So I can double click on this. Yeah, it auto fits. So that can be another approach, but notice when I do the auto fitting, it's auto fitting only that specific color. So how do I, let's switch the mask the other way around. So notice I have here, I don't know if you can see, I'm going to do a zoom. I have parts that are 45, 45, and 49, 49, and 171, 171. But the surface area, for example, for these ones differs. So how do I ensure that the next criterion that's being used is the surface area? So I'm saying go with lighter at the top, right? And then smaller also at the top for surface area. It's very easy. You simply right click on that column and you add it to the sort hierarchy. So I do that and now this becomes effective. It has its own weight in the sorting. Now you can have multiple columns. I believe you can add up to 6 extra columns other than file and quantity. And you can add all of them to the sorting order. The primary criterion is the one that's being grayed out or highlighted. And if you might say, okay, what if you want the surface area to become the primary criterion? Well, the only thing you do, you change the order of these columns. You simply drag the header to the left. So the left is the most important, and then the next one on the right of it, and next one, and next one, and next one, right? So you can simply go by, in this case, by surface area. And I can see this is the smallest surface area, 0.49. The next one, 0.45, right? 0.49. Or if I have the mass first, I have 0.45 with 102, and then 0.45 with 200, and then 0.49 with 96, and 0.49 with 133. And maybe at this point, I can actually save another display state. Actually, before I do that, I hope you guys agree that this doesn't tell us too much. We have lots of parts that are almost the same mass or very close. From 0.45 to 100 grams is still blue, right? Because from 100 to 7,000, it's such a big jump that very few of them are being identifiable as being anything other than blue. So what if I add a few extra colors to this mix? So let's see if this, let's see if I remember correctly, if this is the next thing on my presentation, and it is. We're gonna add interval color coding. So notice here I have multiple sliders for this. So let's say from 0 to 100 grams, we're gonna have blue. How do I add a slider around 100 grams? Well, let's find out where 100 is. It's somewhere here. And you simply click on the left of the color bar. So notice there is no button there, but the moment I move my mouse there, the cursor changes to a hand and it says add slider. So let me click there, pick up the same color that I had before. So I don't want a change in color between the two of them. And you can see a blue is added right here. And let me move it just above the 100 mark. Then between 100 and let's say 500, maybe you would like to go to yellow. Okay, so let's add the yellow slider here. Just click on the left, add yellow. Make sure that is really in the neighborhood of the blue. And then scroll down, try to find 500. So I'm gonna say 500, it's somewhere here. I'm gonna click again to the left. I'm gonna add another yellow slider, right? And make sure that this is above 500. And then from 500 to, let's say, 1000, let's add another color. Hopefully nobody's colorblind. I hope you don't mind if I use red and green. If you are, just let us know and we can pick orange or. So let me pick green here. Okay, so I'm going to use green from 500 to 1000. And there are not that many actually. So I can click here again for another green. So you can see right now, there is no spectrum of colors between the two sliders. The change in color, it's abrupt. And this is what I want. And the last from 1000 above, I want to be red. So the same, so heavy parts should stay as red. So take a look how nice this is. I have blue, I have yellow. Actually, it's quite interesting right here. Is you can see the change between blue and yellow, even though they look the same. One is a little bit below 100 grams, one is a little bit above 100 grams. So very nice and easy to create. Allow me to save this as another display state. And let me color this. Oh, sorry, I think I saved it as add display. Oh, I already added a display state. Sorry about that. Looks like I added 2 of them. And I'm gonna call this, let's call it mass color code. So if I go here, I have my mass. So right now I don't really have to be, to spend the time to go through the mass properties of each part. I don't have to use sensors. I can quickly see if a part becomes, if a part is heavier or not. Now, one thing that you're gonna tell me right away is, Alin, but what if I modify one of these parts? Is the color gonna change in this display state? Well, I guess you already guessed the answer. The answer is no, because this is a static display state, right? You need to go again through assembly visualization to reassign the colors and then save it again as a display state. Okay, so pretty nice functionality on using this interval color coding. The other cool thing that you have access to is access to SOLIDWORKS native properties or your own custom properties. And I believe if you're gonna look into this, there are probably, I believe, 15 sustainability properties and another 20 or 26 SOLIDWORKS properties. So quite a lot of them, plus all the custom properties that you add. Now, one thing I'm gonna do, I don't want to lose what I already have done so far, these 4 columns. So I can save this as a style, right? So I can make it available to all my team. I can put it somewhere on the network and save it as a style. So allow me to put it under SOLIDWORKS training files, X-ray machine, and I'm gonna call it, let's say, mass color coding. Okay, and I'm gonna hit save. So that is ensuring that if I, for example, open another assembly right now, let's see if I have another assembly in my short, let's say this assembly. And I want to turn on assembly visualization. I don't have to spend the time to recolor code anything. I simply go and say, hey man, let's load the style, which was called mass color coding. And as you can see, it already works. The only thing here to be aware of is that the values that are being assigned to the sliders are not really going like we had before, like what we had before, 0 to 100 grams, 0 to 100 to 500, and so on and so forth. SolidWorks is simply going to pick the intervals kind of weighted on the number of components that you have here. So the only thing you might need to do is to do a bit of adjustment. So maybe I want to go from 0 to 100 here. I'm going to try to drag this maybe yellow slider down and blue a little bit higher. Yellow from 100 to, let's go to maybe 500, right? That's what we had before. Green from 500 to 1000. There are only 2 of them. And red, everything above 1000. Or you can pick up your own intervals. But what I'm saving here is all the work that I did with picking the sliders and doing all the other things. Okay, so you can save a style and you can load the style. The other thing that I encourage users to do, especially CAD administrator, PDM administrator, is once you have a certain assembly visualization style that you believe is the most popular for your team, and a good one would be something that's related to troubleshooting large assembly performance, is to save that in a assembly template, right? So start a brand new template, load that style there, and then resave the template. So now everybody who's going to use this template to start a new assembly, they don't have to do any work. They simply click on this and automatically they get the columns that they require. Okay, so let's take a look at the properties. For example, the next thing I'm gonna discard this mass and surface area, right? So let's delete this column, and instead of the mass, I want to use something else. So let me go to more and select another property, right? So when you go on this little arrow, it gives you access to those 5 favorites. Usually are the last 5 you used. Then I can go to more to add extra extra criteria for my columns. So notice the first 15 are about sustainability. The next ones, the ones that start with SW, are things that usually you calculate with mass properties or with the surface properties or with sensors. And then we have a few really good and useful criterion for troubleshooting assemblies, right? So like converted to current versions, excluded from BOM. We're going to talk about that in the next few examples. And also you have access to custom properties that you input yourself. So in this case, I have revision as a custom property. So allow me to add that there. And I'm not going to use this manual color coding. Allow me to reset the color bar and then right click on it again and say group identical. And right away, SolidWorks was able to figure out, okay, revision 1 are all the blues. Revision 2 are all the yellows. Revision 3, green. So that is pretty interesting. What else can you do? So after you do this sorting and color coding, well, something that I would say right now, don't even try it, but I would like to demonstrate just for you to see the possibilities of what benefits you can get if SolidWorks fixes a certain problem. What about editing a property directly here? For example, I decided that the piston pin is going to have a new revision level. Notice I can double click here and I can type 4. And SolidWorks automatically assign a new color to that. If I open the part itself in its own window and I go to properties, you can see how the revision was actually bumped up to 4. So is this something that might sound appealing to you? Is it something that you might want to be able to quickly click on something and change a certain property, either to edit a property directly from the assembly? I mean, there are other ways to do that, but this sounds pretty interesting. The only problem to this is if you do the changes in the assembly and then you hit save without having the parts open in their own window, those changes will not be saved in the part file. So that's a bit of a bummer. And I'm going to leave this slide on for a few seconds, if you don't mind, write down this number 609307 and please vote on it, because this can open a pretty unlimited range of possibilities for us, opportunities, right? So when we teach the custom properties course, this would be actually a nice little chapter to add, a new tool, a different technique for changing properties on the fly, without having to have all the parts open, without having to run batch processing tools. Just do it directly in assembly visualization. Okay, so please vote on this, and let's make sure we help SolidWorks to become better. What about selecting components in bulk? So similar to what you have in, and this is revision. Allow me to actually save this display state also. And I'm gonna use revision colors. Okay, so I have materials, part level, top level, mask color, revision color. Good. What about quickly selecting things using the filter, right? So maybe I would like to select everything that has the word disk inside, right? So you can see right now it's hiding everything else. It's very similar in a way with the filter that you had in the feature manager tree, right? So you probably are familiar with this one here, right? So if I take the same thing and I type disk, I can ask SolidWorks to highlight them, but also to hide them. So notice here, to hide everything else, I have the option to filter the graphics view, to also look in the hidden or suppressed components, to have them listed in the feature manager, and also to look in the custom property. So if I use the option look in custom property and I type here the value 3, it's gonna show me all the components that either have somewhere 3 in their names, like this one has sketch 30, right? Or they have a certain feature that contain that, or 3 for cast aluminum, or 3 as a revision. So in this case, it's kind of hard to figure out. But what about if I type purchased? Right, so right now, all these components that you see here, so I have this guy, if I open one of them in its own window, you're gonna see that it has a property that has the value purchased. So just so you know, this is something that we usually do in our custom property class, but it's worth mentioning. So the same thing can be done from the assembly visualization, but it's only about the file name. So if I type, for example, I think I have somewhere here the value 4 for revision, and I would hope to see piston pin, and I type 4, it actually just goes by the file name. Okay, so that's not gonna happen, but it's still quite useful for quickly selecting things based on the filter. But even more useful is selecting things in bulk using this type of information. So for example, each and every one of these guys might be in a different sub-assembly. So that would be hard to select. Well, here, let's type CS. So to see everything that has CS and maybe go by file name. There you go. I can quickly select things that belong to various sub-assemblies, right? And, or I go based on other criteria. It's just a matter of quickly place them in the right location. So I think this adds another layer of capabilities for you guys to be able to get the job done fast. So that's what I mentioned here, suitable for selected components located in different sub-assemblies. What about troubleshooting? Well, I'm just gonna try a couple of things. So first of all, what components are not fully mated? Right, so let's go to assembly visualization, and instead of revision, I'm gonna go to fully mated. Click OK, and in this case, I'm gonna get yes and no, right? No and yes, and let me just ask SolidWorks to reset the colors and again group identical, and I can see the red ones are not fixed, and the blue ones are actually fully defined. This is at the part level. This probably doesn't tell you too much unless you are one of the checkers, because these are in all kind of different sub-assemblies. And it maybe makes sense for this to be able to move, right? You want to simulate rotation or simulate the movement inside the assembly. If I go at the assembly level, so at this level, notice I have quite a few of them that are not fully mated. So again, I'm going to ask SolidWorks to, I think they're already nicely grouped, but regroup them. So all the red ones are not mated. Now, the cool thing about this, I have two rollbacks, one at the top and one at the bottom. So I can hide based on a range, either from the bottom up or from the top down. This probably is not the best example because I have only yes and no, but if I want just to see quickly who's not mated, I can do that. Now, of course, these colors don't mean anything anymore. So maybe I'm just going to click on this to get rid of it. So these are the parts that are not mated. And if I want, I can save this display state. Then let's come back to see all of them. So when I go to my display state, I'm going to say not mated. And maybe I'm going to send a quick email to the designer saying, hey, take a look at this. Are you sure all of these guys don't need any mates, don't need to be fully defined? Right? So you can simply do that quite easily. Maybe another thing that you might want to check, and we do that quite a lot with large assembly troubleshooting, is do you have flexible sub-assemblies there? In order for that to happen, you have to be obviously in the nested mode because that's the only way to see sub-assemblies. And let's go to, again, to more and use the flexible sub-assembly option, right? Now, in this case, it's important to expand this because right now, if I'm asking SolidWorks to, let's say, reset all and group identical, everything is no. But if you go somewhere in here, there should be sub-assembly that are having yes. You guys might remember from the feature manager tree, a quick way to collapse and expand the tree. So you can obviously right click and then run the option collapse, or you can use the little star that you have on the keypad to do the same thing. And for, so after you expand it, or you can, by the way, for the expand would be Shift C, but I'm sorry, fully expand, if I'm not mistaken, is actually the star is fully expand. I'm not going to do it right now because it's going to expand every little part. And Shift C is fully collapsed. Now, in assembly visualization, I wasn't able really to find a way to automatically expand everything. So if anybody knows how to do that, I would really appreciate if you can let me know. Mind you, I didn't spend too much time in trying to identify that. But somewhere here, a little bit of digging, there are sub-assemblies that are, let's see if they are not fully defined. So spring set, let's see, I have a feeling those might be these ones. All right, so if I click on this guy, no. One of this. So maybe this is not the best example to troubleshoot the, oh, there you go. I see a yes here. So spring sets. The spring sets have yes. Now, if I try to, again, group identical, it's not going to change colors because they are sub-assemblies here. But at the very least, you can get a report with what is flexible, what is not. This is probably one of the best reasons to use assembly visualization to create quick visual reports in drawing. So allow me to do that. I'm going to use here a different column. I'm going to go based on the source. So all the parts are either purchased or manufactured, right? So let's go by part maybe first and ask SolidWorks to group identical components based on the source. So you can see I have purchased and, oh, sorry, I said parts, right? Parts. Okay. So I have purchased parts in blue and manufactured in red. So allow me to save this. new display state. And I'm going to call this source. Okay. So with that being said, you can see it here. Let's create a drawing for this assembly. So I'm going to make a new drawing. Let's pick, I don't know, E size if I really want to. And let's add the ISO view exploded. Maybe increase a little bit the scale of the whole drawing. I really love this option here, right? So it's so much easier to go to, I don't know, 1 divided by 4 or something else. And let's place this in maybe diametric mode and color it. And for the colors, let's use the last option, source. There you go. I just created a color-coded document telling my purchaser what is purchased, what is manufactured, or my production planner. And maybe you want to insert also a table here. Let's add a bill of material with parts only. Now there are quite a lot. I hope you guys agree. So I have a feeling that I'm going to regret my decision. One thing I would like to do here is to auto balloon these parts based on this criterion. So let's use the option maybe inspection with auto fit, a tight fit, sorry. And for the balloon, let's use a custom property. Right, and the custom property is going to be the source. So it's a quick way to identify what is purchased. Maybe this is not really the best example because you have lots of too many parts, but right away I can see this is manufactured and this is purchased, right? So it's a quick way to create this type of charts. You can use them for any type of criteria, maybe based on name of the part and the source, maybe the vendor. You can see here, I can, let's see, what was the option here? So the quantity and the name, right? Revisions. And two more things. I know we're almost at the end of our webinar. Feel free to write your questions if you have any in the Q&A area or in the chat. We will address them. Slow down. So I'm just going to mention one thing that I want everybody to be aware of. When you go to the assembly visualization, there are certain columns that would be really useful for troubleshooting the slowdowns. And SOLIDWORKS try to put them together using this option, performance analysis. So when you click here, it's going to give you 3 extra columns. 2 of them, I believe, are very useful. Total graphic triangles, SOLIDWORKS open time. The third one is SOLIDWORKS rebuild time, which I notice a lot of users care about quite a lot. I can tell you, it doesn't have almost any bearing on the assembly performance. And if you want, I can demonstrate that for those of you who want to stay a little bit longer. But this is irrelevant. Actually, it's very confusing, especially if you're looking at the part level. If I go at the assembly level, maybe it makes sense to see how long it took for a certain sub-assembly to rebuild. But these numbers are crazy, and I don't think they are correct. Okay, they are misleading. So what I usually do, I ignore this option, performance evaluation, and I'm building my own columns. And I'm going to give you my preferences. First of all, I'll start with SW open time. How long does it take to load these components, right, for each component? And maybe let's go by part, right? So you can see here, sorry, by part I said, the worst is 0.29 seconds. Then let's add another column, and I'm gonna go with total graphic triangles. Now a little tip here, you have graphic triangles and you have total graphic triangles. So graphic triangles are the number of triangles needed to represent a part, one instance of a component. Total graphic triangles is the quantity of that component. So you have 20 instances, it's going to be multiplied with the number of triangles for 1. And that's actually very, very useful to troubleshoot graphic regeneration time slowdown. So again, I can use this. And then the other thing, if anybody deals with imported geometry, I strongly recommend 2 more columns. So I'm going to add 2 more columns. One is going to be about the number of surface bodies, so surface body count, especially those of you who deal with parts coming from the automotive industry. Many times you have really bad digest files and they come with lots of surfaces. So I'd like to troubleshoot this. This is not a good example here, but that's one of the columns. And then the last one, let me add 1 more column actually, would be the solid body count. So this is a quick way to quickly identify really complex imported geometry parts that have potential for optimization, simplification. There are a few other ones that I might use depending on a case-by-case basis. That's the phase number, can be also very useful. So more about this in our large assembly course that we're going to launch in a couple of months. So let me save this style because it's so useful. So I'm going to call it assembly visualization performance. Right? So if I start a new assembly and I quickly need these 4 columns, I'm simply going to load the style right away. Okay, so I can, if I go, for example, by the total graphics, let's go by total graphics. And I'm going to attempt to drag this bar to something that has more than 10,000 triangles, which is somewhere here. I can quickly identify the ones that are the worst. Now let's go even higher, maybe the top ones. Oh, and one thing I forgot to do is to make sure that these guys are counted together. So let's drag this again under 50,000. So these are the worst. Now, are there opportunities to reduce the graphic complexity? Absolutely. You can draw a cylinder and apply a spring appearance, and you can still have it fully detailed for sub-assembly maybe, or for part level, but then just something that looks like a cylinder and has the right quantity, the right mass at the assembly level. So that's pretty cool. You can do that. One thing I would love if SOLIDWORKS would have here is the same functionality for moving the rollback bar up and down just by clicking, right? So I don't have to go all the way to the end of the tree to find the bar to drag it up. So hopefully in the next version of SOLIDWORKS, we're gonna see that. Who knows? Isolate the components based on a range of values. So in this case, let's go by material. Allow me to maybe load the different style. Let's go to the default, right, where we just have the mass. So instead of the mass, I'm going to go with material. So what material do we have inside these parts? And I'm going to go and color them by material. Actually, I don't really care about coloring. It's mostly about sorting them. Now, let's see only the spring steel parts, the parts that are made out of spring steel. Notice I can move this rollback bar down and this one up. So it's a quick way to identify the parts that are meeting that specific criterion. And then save this as a display state. So if I go now to display states, I have one called spring steel. Spring steel parts. So if I go here, there you go. That's all I have. And I would like you to use your imagination about what type of components you need to isolate, maybe based on whatever criterion you want to use, right? So Let's move this back to the top and move this back to the end. The last, I don't know if I have another one. Oh yeah, you can save all your reports in the Excel format. So for example, remember those 4 columns that I told you I care about? I'm using this a lot for benchmarking an assembly that comes from one of my customers when they want to work with us for a large assembly service. So if they have really slow assemblies, the first thing I do without modifying the assembly, I open it and I create this report. And then as I optimize my assembly, I compare the results of what I'm getting with the original results. This way, I can go back to the customer and say, there is an opportunity to make this assembly open 50 times faster, or to reduce the total graphics triangles with no loss of detail by 5 times. So the graphics, the lag is going to be reduced or is going to be eliminated. So how do you do that? Let me load again the style for the assembly visualization performance and simply save this as an Excel spreadsheet. Notice you can sell for top level and parts independent of each other. And I usually include also the hidden components for this type of performance type numbers. So if I go to SolidWorks training files, it was here, and I'm going to call it engine. Right. And if I open that Excel spreadsheet, you're going to see something like this. I just have to add the last line. Okay. So just as a summary, we presented 12 different ways to use assembly visualization to get something out of SolidWorks. As you can imagine, there is much more that it's available there. But once you know how to use the tool, you should be able to find new ways for using it and getting value out of it. So if there are any questions, please write them down. We're going to try to answer. I'm going to leave this slide on in case you would like to get access to some free resources, free tech tips and training resources, either video-based or article-based. So let's see the questions that we have so far. Ramtin is asking if we're gonna receive if you're gonna receive a recording of this seminar. Erin, can you confirm that this has been recorded?
Yes, yeah, we'll be sending it out tomorrow morning. So just look out for an email from Aaron Elliott, and you'll have it.
Excellent. And I want to give you one more resource that Erin is going to include. If you simply run, go to internet, and unfortunately I don't know the link. She's going to give it to you. Just Google my name, right? Alin Vargatu. The first option that I get here, it's author at engineer's rule. It might be the second or third in your case. If you click on this, you're going to see a bunch of articles that we wrote for this publication. And right here is the X-ray machine for SolidWorks assemblies. Here I'm talking only about 10 ways to use this tool. In my presentation, I showed you 12 different ways. So if you'd like, for example, something like this to refer to, you can go to this there. If you were to print this, there are about 52 pages in this article. So it's pretty well detailed. Okay. Okay, let's see what other questions. So I see that you'd like to get mask, fasteners, ability to hide and show components. Is the only way to have a dynamic assembly visualization to save a style and turn on assembly visualization to check frequently? So Grant, I believe what you're asking is there a way to have these colors updating dynamically? And you provided the answer yourself. At this point, the only way to have that updated dynamically is to use the assembly visualization tool. And I think there is a good reason for that, because it's actually quite computationally intensive on a large assembly, right? So if I would have that updating all the times, probably would take a long time. That being said, you might be able to create a macro. You press a button and it's going to update the colors on that display state based on whatever criterion you have in the assembly visualization. That sounds actually like an interesting challenge. Who knows? Maybe we're going to give it a try. Any hope to get some of all of this functionality into large design review? I guess the only one that would make sense to get would be the graphic triangles, because that's the only thing that large design review loads, really. So maybe send me an email, Grant, with what type of functionality you'd like to see, and let's put our minds together, see if we can find something that makes sense to present to the SolidWorks devs. And I don't see other questions. Is anything in the chat? Let's see. No. Okay, so looks like there are not that many questions. Thank you very much for attending this webinar, and take a look at what other webinars are coming up. Erin is going to send you the full schedule, and also send us some requests. What type of topics you'd like to see? Surface modeling, really crazy use of the SolidWorks tools and techniques, maybe some areas that are more advanced but more narrower, like piping, tubing, electrical. Let us know, and we're gonna try to put together a presentation that's gonna cater to your requests. Thank you very much.